Hi students, let's study 10th standard ICSE Math, Chapter 19, Constructions. Note down all the cancellations. These are all easy sums. The picked ones are the ones I'm going to do right now. And the remaining ones are for homework. Let's start with the first sum. Draw a circle of radius 3 centimeters, then mark a point P, 5 centimeters from the center, and from there, draw two tangents. That is, two tangents from an external point. They will be equal in length. So let's start. Radius of 3 centimeters. Perfection is required in this chapter. I'm going to leave a lot of space because I reckon it will be required. I like to read the book rather than the compass. Next, 5 centimeters away. It's here. That's point P. Now two tangents. They should be perpendicular to the radii respectively. So first of all, join them. We'll draw a perpendicular bisector of this thing. So from here, far away, to prevent congestion. Join these 2 points. Double check and then do it. Dash lines. This is the midpoint. Now, taking this as a radius, cut an arc here and cut an arc here. Now I can join them. Check, check. Perfection achieved. Marked as A and B. Also, they say measure the length of each tangent. It comes out to be 4 centimeters. 1 millimeter difference is allowed. Anything more is not allowed. Next, so we have to write it. AP is equal to BP is equal to 4 centimeters. Now, the third sum. Draw a circle of diameter 9 centimeters. Mark a point at a distance of 7.5 centimeters from the center. Draw tangents. Oh, that's the second sum. Third sum is draw a circle of radius 5 centimeters and draw two tangents to this circle so that the angle between them is 45 degrees. So first we should draw this rough diagram. The radii are 5 centimeters. The angle between the two tangents is 45 degrees. Now we know that the radii and the tangents are perpendicular, and this is a quadrilateral, the sum of angles should be 360 degrees. That means the angle between the two radii is 135 degrees. So that's how we'll draw this. First we'll draw the circle, then I will draw one radius, then I will draw another radius at 135 degrees angle, and then from here I will draw 190 degrees, and from here I will draw another perpendicular, and they will meet at a point, and these will be called the tangents. So here I have drawn one circle with radius 5 centimeters. Now let me draw another radius at 135 degrees. Now how to get that? Well, let me extend this first a little bit. That's 180 degrees totally. Now, out of this, now I can get 60 and 120. Use the same radius. So from here, cut an arc that is 60 degrees, and from here, cut the arc, same measurement, 120 degrees. So I got 2 points. This is 0 degrees, this is 60, this is 120, and this is 180. So 135 will be between 120 and 150. So first I should get 150. That will be by bisecting 120 and 180. Protractor is not allowed. So from here, I'm gonna put an arc outside. Put an arc. I'm gonna use pen, but you don't use pen. Use another pencil. So I'm just gonna make a mark out here. That's the 150 mark. And now from 150 and 120, I got one point of intersection out here. So that's your 135 degrees. So let's mark a radius. So I got two radii of 135 degrees angle in between. Now I have to draw a perpendicular to this and a perpendicular to this. Those will be the tangents. How to draw a perpendicular? Well, extend this. Similarly, extend this. Okay, so from here, cut an arc and cut an arc. They're not meeting, then make them meet. Point, 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 point. Similarly, from here, to manage too many instruments at the same time here. Don't do guesswork. Don't just assume that you can get the perpendicular with your free hand. You have to show the constructions. Perfection achieved. And now labeling. O, A, B, C. The two tangents will be equal. Right here 135 degrees, 90 degrees, 90 degrees, and most importantly 45 degrees. If you have a protractor, you can check it. It will be 45 degrees. If it is 1 degree off, it's okay. Next, the 15th sum. Draw a circle circumscribing a regular hexagon with side 5 centimeter. Well, we are going to do a shortcut method. First, I will draw a circle of 5 centimeters. Next, from any point, I'm going to start cutting 5 centimeter marks. Check. Yep, it works. I'm going to join them. Point, point, and then join. First mark the points. Point, point. You should do it when you have a lot of time. If you do it in a hurry, it will never be perfect. So this is the circumcircle for the hexagon, touching each vertex of the hexagon. But we can't do this in exam. We should draw the hexagon first and then draw the circumcircle. But that's okay. We'll just add a couple of perpendicular bisectors, so it will seem as if you've drawn it later. So point, point. I'll draw another perpendicular bisector. And the perpendicular bisectors will definitely meet at the center of the circle, which is called the circumcenter. Do one diagram per page. And start drawing, keeping in mind that you have enough space for the rest of the diagram. Because if it doesn't fit in the page, you'll have to redraw it on the next page all over again. You should have foresight. So yeah, they meet here exactly where the circumcenter lies. Next, they want 16 sum the in circle of a hexagon with 5.8 centimeters. So first I will draw the hexagon, for which I will draw the circumcircle with 5.8 centimeters radius. I don't know why some students do it once, twice, thrice, 4 times. Don't do it like that. Just do it once smoothly. And never touch the pencil or this arm. Always touch this arm, that's it. So from any point now, I'm going to make 6 arcs of the same radius, 5.8. Oops, I think something is not perfect. It moved a bit, so all my measurements are off. I have to redo it, I guess. Let me quickly mark the correct points. 3, 4, 5, 6. So now the hexagon. For circumcircle, we draw perpendicular bisectors of the sides, be it a triangle or a hexagon. For incircle, we draw angle bisectors, and where they meet is called the incenter, which for a regular hexagon will coincide with the circumcenter. Regular in the sense all sides are equal and all angles are also equal. So now angle bisectors. Let's start with this angle. So now point. Yep, as predicted, they met at the circumcenter. Now it is the incenter. Yeah, you have to show all these dashed lines and arcs because the checker will check if you've done it or you've just done some shortcut. Now what's the radius we're going to take? For circumcircle, the radius was from the center till the vertex. But now I can't just take it from here to the side. I'll have to draw perpendicular to the side. So from here, cut one arc. From here, cut one arc. I guess it's too small, so I have to increase this a bit. Yeah, better. Now I got the intersection point here. Now from here to here, that's a perpendicular bisector, and this is the point, and this is the radius. This is the perfect radius. So let's hope that it touches all the sides perfectly. Just missed it. I have to increase a little bit. I'm using a pen, so there is some difference. Okay, 2 touched, 3 touched perfectly, 4 touched perfectly, 5 touched perfectly, and 6 touched perfectly. Wow. I knew that. I was supposed to be an artist. Voila. All 6 perfect. If you miss one, it's okay. What else have they asked? They might have asked to find the radius as well, but not in this case. Now the 19th question. Construct a triangle ABC in which the base is given, AB is given, and angle is given. After constructing the triangle, draw a circumcircle and then draw a cyclic quadrilateral. Wow. So first we should always draw the rough diagram. Construct triangle ABC in which BC is the base, 5.5. Freehand is okay, 5.5 centimeters. BC. Then angle ABC is 120 degrees. It's an obtuse angle. Please understand, it's not acute angle. 120 degrees. But for this, we can't use protractor. We'll have to use the compass. And AB is 6 centimeters. So AB is 6 centimeters. And then join A and C like this. And then you have to draw the circumcircle for this. So first draw the triangle. So first the base, 5.5 centimeters. BC. Now 120 degrees out here. Cut one arc. Using my left hand here, proving to be difficult. Okay, same measurement. Cut here, that's 60, and from here 120. 60 was not required, but It was a habit. So now mark a point. Always mark a point first. It's easy to join 2 points. Perfection. Imagine you'll draw plans to make a space rocket tomorrow. Yeah, you'll use a computer, but these skills make you a better creator. Now AB, 6 centimeters. I got A. And now join AC. Ink is smudging, that's why we never use pen, use pencil. Don't fast forward, what's the hurry? 5.5 centimeters, 120 degrees, 6 centimeters. Now we'll draw circumcircle, so Roman number 1. Let's draw 2 perpendicular bisectors of the sides. And take it outside, please, not inside the triangle. As far away as possible. Don't be, should not look congested. Point. Now of this. So where are they meeting? Out here, outside the triangle. That's the circumcenter. Oops, I did not have the foresight. I got so lost in talking that I forgot that the circle won't fit here. Should have started drawing in the center of the book. So make sure you do. Oh, it's passing through B. Good. Let's hope it passes through C exactly. Have to take a little bigger radius. Should erase it. I'm not doing it. And I'm not drawing a complete circle, but you should. If typically you'll just cancel the whole thing and redo it on a new page. I'm not going to do that. So that's your circumcircle. Perfect. Well, almost. Now, Roman number 2. Draw a cyclic quadrilateral A, B, C, D such that D is equidistant from B and C. Now that's a problem. When we say equidistant from B and C means it lies on the perpendicular bisector. So, wherever this line touches the circle, that is one option. But I've got another option. Even this is equidistant from B and C. So, problem solved. I'm just going to join this and this. Oh no, that's not ABC, it's ABDC. So, imagine that there was a point here. Okay, and then you would join that point and that point lying on the circle. And that would be ABCD, cyclic quadrilateral. And that point would be equidistant from B and C because it would lie on the perpendicular bisector. So that is why it was important for you to complete the circle. I should have started this diagram in the middle. Next, 20th sum. So again, construct one triangle. Data is given. And then draw a circle with BC as a diameter and find a point on the circumference which is equidistant from AB and BC. See, when they say equidistant from 2 points, that means it lies on the perpendicular bisector. But when they say equidistant from 2 sides, that means it lies on the angle bisector. So 20th sum. BC is the base, 6 centimeters. BC, 6 centimeters. Then ABC is again 120 degrees. Good, it's easy. But do you know how to do 45 degrees, 135 degrees, 75 degrees, 30 degrees, 15 degrees? You should know all of that. And AB is 3.5. Okay, this is A, so 3.5. So that's your triangle, ABC. Next, they want us to draw a circle with BC as a diameter. Do something like this. Then draw a point P on the circumference which is equidistant from AB and BC both. Means angle bisector of ABC. Like this. And it should be on the circumference of the circle also. So this is the point. Satisfying both the conditions. Satisfying the condition that it is lying on the circumference and also on the angle bisector of ABC. That is 60 degrees and 60 degrees. So that it is equidistant from AB and from BC. It is equidistant. And then they said measure BCP. BCP. Wow, this will be interesting. Let's hope the measurement comes out to be correct. Let's start drawing. Yeah, drawing the rough diagram gives us a plan, a strategy of solving the sum and to figure out from where to start, from the middle of the page or where. So again, I'm assuming that this should be a sufficient place to start the diagram from. BC is 6 centimeters. 120 degrees as usual, cut an arc. And from here, obtuse angle, not acute angle. And then AB is at 3.5, so here we go. A, join the AC. Now, BC is a diameter. So what's the radius then? Half of it. How do I find half of it? Draw a perpendicular bisector? No, I'll just use a ruler. 3 centimeters. This is the midpoint. Check, is it equidistant? Yeah, so let's draw a circle. I would have preferred rotating the book, but there's no space because this camera stand is in between. Alright, now I'll draw the angle bisector of angle ABC. I'm going to use the same arc which was already there. Cut an arc here, and from here, cut an arc. Here's the point of intersection, and here is the angle bisector. And where it intersects the circle is point P. And now they want us to measure BCP. Yeah, BCP. It's Roman number 3. Please write here Roman number 1, Roman number 2, Roman number 3. Angle BCP. Well, use a protractor now to measure it. It should come out to be 30 degrees. 30 degrees. 1 degree off is okay. Finally, the 21st sum. Construct a triangle. Once again, 3 sides are given. Construct the incircle and measure the radius of the incircle. Okay, it's easy enough. I'm going to just start. I'm not drawing the rough diagram, but you have to. Don't be lazy like me. BC is the base, 6.5. I'll just write all the measurements. AB is 5.5. So draw big arcs. And AC is 5 centimeters. Your hands should be very steady. Point it first of all. Point it and then join them. Point and shoot. Point, shoot. A. This is 5.5 centimeters and this is 5 centimeters. Now construct the incircle. Well, we need angle bisectors for that. 2 angle bisectors, not perpendicular bisectors. So cut an arc. Then outside. Point of intersection. Got it. Be very careful to find the point of intersection. Dashed line. Next, similarly, draw a small arc here. Now from this point, draw an arc here. Any measurement, but same measurement for the second arc from this point. Not meeting, so do it again from this point. Extend it. Yeah, now they're meeting exactly at this point. So I got the incircle, but for the radius now I have to draw a perpendicular bisector. It was not an equilateral triangle, so I have to get 2 equidistant points on the base. I'll draw an arc here. So I got 2 points here, 1 point here and 1 point here. So that from these 2 points now, I'll further draw arcs outside. So I got a point of intersection here. Now when I join them, point, shoot. That's a perpendicular. So this will give me the radius. It should touch all 3 sides perfectly. All 3 sides should be tangential to it. One side error is okay. Let's see how it goes. Oh no. Facing some error. Remember, there should be no double lines or thick lines, there should be thin lines. So my circle is not perfect. It's touching only 2 sides. And it's a bit thick, which is not allowed. Double circles are not allowed. Should erase it. So you do it perfectly. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.